All right, today we want to talk about concentration. If you remember the other day, we talked about solutions and solutions being typically, at least in this class, aqueous, meaning substances that are dissolved in water. Now, obviously, there are other forms of solution. For example, gas in a gas. Air is an example of that, which was one of the questions that you guys answered. But again, we're talking primarily aqueous solutions here, and there are multiple ways to calculate and show amounts of solute in a solution. So there's three ways. The very first way is by percent. And it bears mentioning that all of these calculations are going to be following this general formula. Concentration is the amount of solute that you have in a solution divided by the amount of solution you have. And again, there are different measurements that we're going to use depending on the nature of the solute. So for example, you probably would not want to measure a liquid solute in grams. And you probably wouldn't want to measure a solid solute like table salt. You probably wouldn't want to measure that in milliliters. And yes, I know if you're a cook, you might measure, they don't say add 9 grams of salt, they'll say add a half teaspoon, I know, or they'll say add 5 milliliters, or what have you. For science, it's going to be a little tiny bit different. So, for percentages, the very first type of percent we're going to talk about, oops, caps lock is on, is called percent volume. And the way that it is written is going to be a percent symbol and then V over V. And you know me, I hate the slash. I like to have, when we're doing divisions, to have it written like this. And that's what we're going to do when we actually do the mathematics here. So the formula for percent volume concentration is the volume of solute divided by the volume of solution. And then we multiply, because it's a percent, we multiply that by 100. So this is used when you have a liquid solute. So a good example of a liquid solute would be something like hydrogen peroxide. So let's say we measure out $15 mils of hydrogen peroxide, and we mix that with 235 mils of water. So the nice thing about these volume calculations is, since these are both in milliliters, we don't actually have to do any conversions. If both of your units match perfectly for a percent, pardon me, you're good. So if we're talking about liters and liters, you're good. If we're talking about milliliters and milliliters, we're good. So everything's perfect the way it is. So we're going to do volume of solute divided by volume of solution. So I'm going to say C equals my volume of solute, 15 mils H2O2, that's hydrogen peroxide, 15 mils of H2O2 divided by, and here's where people are going to make a little bit of a mistake. I know I said 235 mils of water, but we're not going to put 235 down here. Remember, we've added two liquids together. So the total amount of solution is my peroxide plus my water. So 235 and 15 is 250 mils. And I'm just going to go SOL apostrophe N, just as a short way of writing solution. So we'll do the math, and we get 0.06 times 100 is 6.0%. And we can say volume. So in other words, if you took 15 milliliters of pure hydrogen peroxide and you mixed it with 235 milliliters of water, you would get 250 milliliters of solution total, and the concentration, in other words, how much solute is in there, is 6% volume for volume. I'm going to do one more of these. I'm going to do one with isopropyl alcohol, and I'm not going to write out the chemical formula for isopropyl alcohol. I'm just going to use the word iso, and it's a little bit of a topical thing because people are using a lot of isopropyl alcohol to disinfect things, and it's one of the ingredients in some hand sanitizers as well. So I have actually a bottle in the bathroom that I have in my office now, and I actually have mine's a 99% bottle, and we're not going to use 99%. I'm going to just ballpark the numbers, but I'm going to say we have 340 mils of isopropanol in a 473 mil bottle of solution. So they're giving us this now as the solution volume itself. So again, we do the same formula. So volume of solute up top, I'll say 340 mils of iso divided by 473 mils of solution. Then we multiply by 100, and we get our answer. So I've got my calculator with me. 340 divided by 473 times 100 is 71.8. Nope, 71.9%. And that's going to be, again, in volume over volume. But what if you want to go backwards? What if you have the percent concentration and they're asking you, okay, how much solute is in there? So I'm going to change it around a little bit. I'm going to say, for the next question, how many milliliters of ethanol are in a 750 ml bottle of wine with alcohol by volume of 12%. So in other words, this time we're given the percentage and we're given the total amount of solution, and then we have to go backwards. A question like this is actually, for those of you who eventually may do some time at a restaurant as a server, or do some work as a bartender, this might be something that you have to think about a little bit. Also, if you volunteer when you are of drinking age in some kind of location where there is alcohol being served, we have to make sure that we do not overserve people. And part of avoiding over-serving is actually making sure that we're aware of how much alcohol an individual has consumed. And so there are different programs in for serving that basically will make you calculate these, and that gives us an amount called a standard drink. But anyhow, that's for your futures when you get into the workforce and you work in bars or restaurants, or you volunteer at things like Folkfest. But anyways, so how do we find out how much pure ethanol is in this bottle of wine? Well, whenever we do a question like this, I'm going to write out the original formula, and then we're going to do a little bit of math because we need to isolate a specific variable inside the formula. So we have C equals volume of solute, and solute is what we're after in this case because ethanol is the solute. So it's volume of solute, divided by volume of solution, SOL apostrophe N, and then times 100. So in order to isolate V solute, we have to do a couple things mathematically. First thing we need to do, and since you guys as a class are relatively strong in the math, I'm going to go over this step by step the first time, and then after that, not. So the first thing we need to do is divide by 100%, and that's going to let us get rid of 100% on that side. So we're starting to isolate V solute, and then I need to multiply both sides by V solution. And I'll multiply by V solution on this side as well. So that lets us get V solution off of the bottom, and now we have a formula that has the correct thing isolated. So I have V of solute equals concentration divided by 100 multiplied by V of solution. Piece of cake. So now we just have to plug in the numbers and we are good. So our numbers are, concentration was 12% divided by 100% multiplied by 750 milliliters, and that will give us our volume of solute. So 0.12 times 750 gives me 90 milliliters of ethanol. Okay, so that's volume for volume. So the next kind of percent is called percent weight by volume. And yes, again, this is something that in chemistry we don't see very often in real life. It is used for consumer or household products. So what we need to do in a situation like this is take the mass of the solute divided by the volume of the solution. So I'm going to say mass of solute divide by the volume of solution, and then times 100. We're not going to go backwards on this one. I'll just give you an example. So let's say you are making a salt solution. You're making a brine. Now in chemistry, we'd probably use a different kind of concentration measurement, one that we're going to talk about later. But if you're making a brine at home, for example, maybe you're making, I don't know, cheese, because you can make cheese at home. Maybe you want to dissolve something like 5 grams of salt in 100 milliliters of water. So the calculations are very simple. We're going to say 5 grams divided by 100 mils of water times 100%, and that's going to give us 5%, and this is weight by volume. So this gives us the ability to talk about dissolving a solid in a liquid. Again, not the one we would use in chemistry, but one that you need to know about. So the third kind, and let's see if I can actually scroll. I might not be able to scroll anymore. No. I'm going to pause and make a new page here. And we're back. Okay. So the third kind of percent is called weight by weight. So it's a percentage, it's weight by weight. So again, this is going to be mass of solute, divided by mass of solution, and then times 100. This is useful when you have two solids. And a really good example of some solutions that are made of solids, you answered that correctly on the last little homework bit, were alloys. So alloys, remember, are metals that are melted together in a particular proportion, and they have cool properties that are sometimes intermediate or between the two metals that made them up. Sometimes the properties are actually completely different. For example, copper and tin to make bronze. Bronze is actually harder than either copper or tin alone. Copper is soft and tin is soft. When you melt them in the correct proportions, you have bronze, and it is harder. So let's make some bronze. So I'm going to say, let's take 15 kilograms of copper and 50 kilograms of tin. We want to know the weight percentage. So in this case, remember, the solute is always the chemical or the element in here that is the most plentiful, the thing you have the most of. So tin is going to be my solvent, and copper is going to be my solute. So if I have 15 kilograms of solute, and I'm just going to say 15 kgs of Cu, now my total solution would be 15 plus 50, that's 65 kgs, and I'll say of solution multiplied by 100. So I'll do my little bit of math here. And we get 23% weight for weight. So that's percentage concentration. So I'm going to stop this video, and the next video is going to be on parts per million, another kind of concentration measurement.